Here is a quick example that will hopefully tie some of the loose ends together with some real numbers so that you can see how MAR and MNAR can bias the results. So here what we have is some simulated hypothetical data. We have SES and math scores, and these are incidentally correlated at approximately 0.5. And so in this case, we have complete data, so it's great. This is what we would see if we managed to get complete data from everyone. We have a mean of about 50.74, as you can see. And just to reiterate, SES in this case is called an auxiliary variable. An auxiliary variable is a variable we collect that we believe is predicted with the missingness and the DV, and we use it in the analysis to impute, later I'll show you how to do this, but we use it to impute scores on the DV that we have missing because it is correlated with the missingness, so we can estimate that. The computer does it, but theoretically it can be estimated. And it is a variable that's not a focal interest to us. So it's almost like a control variable, but it's used for a different purpose than we have previously talked about covariates being used. So again, based on previous knowledge of the literature or of the practical setting that we're working in as a practitioner, we have reason to predict that those of low SES are more likely to skip the math test than those of high SES. And incidentally, those same individuals will also be lower in math ability as well. So their true scores, we believe, will be lower. And so that is something that we're going to add to our data set. We believe that it's a variable that will be easy and relatively cheap to collect, let's say. So that's kind of important because every additional variable you use in a study, of course, has some cost attached to it. So that's important to think about, but the proper term for this is auxiliary variable. It's not a covariate, so use covariate only for when we want to parse out variance in the DV. Remember, soak up irrelevant variance. This is slightly different. This only has to do with missingness. So when I say auxiliary variable, we should think this is for missingness. This is to predict missingness and be able to impute values appropriately using these auxiliary variables.